Welcome to QCA's Compliance Committee's second sponsored webinar. I hope you all had a terrific 4th of July and am looking forward to seeing many of you at ASI in Chicago next week. But let's get back to the reason you've joined us today. Lewandowski is a toxicologist with Gradient. He will be speaking on chemicals risk assessments, evaluating the chemicals you choose to put in your product as opposed to the product itself. Tom was our invited guest this year at the annual QCA dinner held during ICFSO in Orlando. He graciously agreed to host this webinar when the noise level in the restaurant precluded a discussion. Those of you who heard the 2 panels at ICFSO that Tom sat on know we are in for an informative and instructive discussion today. With that, I'll say thanks again to you, Tom, and let you take it from here.
Well, thanks, Steve, for inviting me to give this webinar. And again, also for me as well, good afternoon to all attendees. And for those in the U.S., I hope you had a nice 4th of July holiday. So the focus of today's webinar is, as Dee mentioned, chemical risk assessment, and basically using that as a means to understand potential risks and liabilities in your products from the chemicals that you might have in those materials. So just a brief outline of what I'm going to cover today. So I'll say a little bit about chemical risk assessment, what the process is, how we go about it, and I have some illustrative examples to show you that might be relevant to some of your products. I'll then say a little bit about hazard versus risk, sort of 2 key concepts that are emerging today and that maybe have different takes on what a product might mean for a member of the consuming public. And then in response to some questions from Dee, I wanted to say something about certain chemicals of concern, bisphenol A, phthalates, and PVC, which I know are of concern to some of the members here today. And finally, I'll conclude with a little discussion of EPA's TSCA work plan and some of the chemicals that are going to be looked at on the horizon, just to give you a heads up about what might be coming down the line. So first, maybe just a sort of a rationale slide as to why we'd even want to consider chemical health risk assessment. Why would you want to do this for your product? It obviously could take some additional time and would be some additional effort. And I think obviously the first reason is to really ensure the safety of the product for the users who will actually be using it. I think that's pretty much the paramount concern. But also I think you want to maintain customers and sort of maintain brand reputation. Obviously the last thing you want is for someone to come up with a problem with your product, some sort of health problem with the product, and then damage the brand reputation. That obviously is not a good thing. We also can do risk assessment to communicate risks to concerned parties, whether that be consumers or customers or regulators. And then we can also use risk assessment to maybe avoid lawsuits, to avoid recalls, or if a recall is necessary, to determine how broadly it must be conducted. And then finally, an important consideration is to avoid lawsuits down the line. So if we can design and develop products that are free of chemical hazards or have minimal chemical hazards, then we can potentially avoid legal problems down the line. And so all of these things can be addressed by conducting a chemical risk assessment. Now, just as a sort of maybe starting point, I just wanted to give you some perspective. So there certainly can be challenging to communicate with the public some of these concerns about health risk. And so if a member of the public was told that a beverage container they would be using is leaching a chemical that is shown to cause cancer in rats, or if they're told that a promotional product contains a chemical that's known to cause birth defects, or straight from the headlines, if they're told that a food product they're consuming contains the same chemical used in producing yoga mats, how do you think the public is going to react, right? So since this is a webinar and I can't actually poll the audience, I can pretty much tell you that the typical reaction of the public is something like this, right? Sheer panic. They hear this about birth defects or cancer, and they completely freak out, and the gut reaction takes over. They're not really paying attention to any facts. And so one of the roles of risk assessment is to provide people with those facts and try to provide some context for that information that's just been communicated. So what is a chemical risk assessment? As sort of defined by the National Academy of Sciences, risk assessment is the process of determining a chemical's potential or likelihood or probability, those all pretty much mean the same thing, for causing adverse health effects, right? So it's really trying to quantify things. And as we conceive of it, there are basically 4 parts to a chemical risk assessment. The first part is hazard identification, where we basically look to see what health effects are known, what health effects are possible. It's a very broad sort of type of question. What could possibly occur? Once we get through that stage, then we start looking a little more carefully and say, well, at what exposure levels do those effects occur? That's the dose-response assessment. And simultaneously, we try to evaluate the exposure level. So, at what level of exposure is this product associated with a particular chemical? If someone is using this product, what level of exposure might they experience? And then we can put that exposure information together with the dose response information and try to estimate what the actual risk would be in a quantitative way. And the questions you might ask there are, how large is the risk that we're going to be experiencing here? Is it too large? Does it exceed some sort of regulatory threshold? Does it exceed maybe the comfort level of the company involved? Basically allowing you to make some sort of quantified determination about whether action needs to be taken. So I wanted to give 2 examples here because obviously risk assessment can really vary in the level of detail that's required and the amount of effort that's really required to carry it out. So a very simple type of risk assessment would be something looking at lead in a beverage mug or maybe a painted product, a product that has been incorrectly painted with lead-based paint. Now, in the case of lead, we understand the hazards quite well. That's very well established. We know that lead is a developmental and reproductive toxin. That's really clear. We also understand what levels of lead might be harmful. So that information from the dose response side of things is really clear. We also have very well established methods for testing the level of lead in various products. We can do totals metals testing, or we can do leach testing to look at maybe what might be present in someone mouthing, a child mouthing a lead-containing part, for example. So we can get a really easy estimate of exposure. That's fairly well established. And from the risk characterization side of things, we actually have some very good reference values for lead. We know sort of what levels are of concern, and we have regulatory criteria for what levels of lead are acceptable. So in the case of lead in a product, the risk assessment is fairly straightforward and not particularly complex. However, you can certainly have more complex situations. And so a more complicated risk assessment might be something using a chemical, for example, like Tenuvin P, which is a UV stabilizer commonly found in a number of plastic products. And in this case, the situation is less clear. So this is not a chemical that's commonly as well used as lead. It's certainly not been as well studied. So we might need to spend a little more time understanding what the chemical hazards there are, what the health hazards are. We might need to sort of dig a little bit to come up with the data. We may also need to do additional work to understand what the dose-response relationship is. So how much of this chemical really is a problem? I think that's something that would need to be explored a little further. And it's also possible that depending on the material involved, we might need to come up with a test method to actually quantify this chemical. So it may be that if it's in a plastic material, a particular type of test method might need to be developed. And finally, in terms of risk characterization, reference values may be lacking. So again, we may not easily be able to understand what we do with all this information once we get it. We'll have to do some work there. So this is just to point out that risk assessment comes in different flavors and different levels of effort. Now, an important concept in risk assessment is the idea that risk is a function of both exposure and toxicity. And the sort of corollary to that is that without exposure, you have no risk. So no matter how toxic or hazardous a chemical is, if there's no exposure to it, there is no risk. And while that may seem completely logical and straightforward to you, it's really the case that this is often something that's really sort of left aside. Again, when people hear of a particularly toxic chemical, they don't stop to think about exposure. And so we really need to sort of bring exposure back into the picture to understand what the actual risk might be. So again, the message that without exposure there is no risk is a really fundamental one that I think we all need to keep in mind. Now, in terms of how we determine exposure, toxicologists talk about both exposure pathways and exposure routes. And an exposure pathway really refers to the way in which a person may come into contact with a particular chemical. So how does the chemical get from the product to the person? And that basically occurs through a number of different exposure routes. And so we can think of cases, for example, where there might be inhalation. So there may be, for example, off-gassing of a product in its packaging, in its plastic packaging. When the package is open, then the chemical that's gotten into the air inside the package can actually then be inhaled. Ingestion is actually a really important route of exposure, particularly for children. So as the picture there shows, we've got a child putting a cell phone into their mouth. Kids do that all the time. And so direct mouthing of products is a particular concern for children and is often kind of a key driving scenario in risk assessment. It's also true that for both adults and children, this idea of hand-to-mouth or hand-to-food contact may also be significant. So if someone is coming in contact with the product and then they use their hands for eating, there may be transfer of the chemical from the hand to the food and then ingestion that way. So that may also be something you would need to consider. And finally, maybe most important for skin, for promotional products, could be skin contact. So for wearable items, for example, you may have direct contact with the skin and the potential for chemicals to migrate from the product to the skin surface where it could cause some effects. And I have one case example I can show you about that on the next couple of slides. It's also true that if you're marketing a product or maybe some sort of packaging related to lotions or creams or other things that are placed on the skin, that could also be a source of concern and a source of exposure. So just two examples to kind of illustrate how you would go through this process. So first of all, the first example relates to a beverage container. And this actually relates to a particular project I worked on maybe about 10 years ago. And the concern here is that if you've got this beverage container that's coming into contact with a hot fluid, chemicals could potentially leach out of the container into the beverage. There could definitely be migration there. So how would you evaluate that risk? You could certainly do leach testing, basically a long extraction of that particular material in some sort of aqueous fluid. You could use that to actually estimate how much of the chemical would come out into the fluid that might be consumed. But you would also need to consider how much of the typical 2 liters per day of fluid intake that we all have, how much of that would actually involve the container, because obviously someone may not be consuming their entire daily fluid intake through that particular container. It's also important to know how long someone might use that container. Is it going to be used, for a period of the whole lifetime, or maybe just for a period of a couple of weeks? Those are things that you would have to make assumptions about. And finally, some of the more interesting science issues, the temperature and acidity of the beverage could be an important consideration because those actually might enhance leaching depending on what the chemical actually was. Chemicals that might be of concern in such a case could include lead, which is often used as a stabilizer in some plastics, phthalates and BPA, which are also present in a number of plastics, and then also potentially things like diamines or other resin components that might be part of the actual structure of the material, which may be present in residual amounts. And so I mentioned I worked on a case about 10 years ago. This involved a beverage container insert, actually, that was leaching acrylamide, or was reported to be leaching acrylamide. And so the question was, was the leach testing method used appropriate for this particular chemical? And also then we needed to consider how often and how long someone might actually use this product. The concern was actually a lifetime of exposure because acrylamide is regulated as a carcinogen under California Proposition 65. So we really were looking at a lifetime cancer risk from this particular product. And I will say that this was a case of a sort of fortuitous or maybe anti-fortuitous finding. And the question was, do we need to recall this product? Do we have a crisis here? And we found out that the levels of acrylamide that were present in the leached material were below the Proposition 65 reporting limits. And that's also considered a non-significant risk level. So therefore, we considered there wasn't a health effect as it would pertain to this product. I will also say that in this particular case, it was found that the acrylamide detected in the leachate was actually a lab error. And so actually the problem went away fairly quickly, and I think is a good example of why you need to carefully look at any sort of test data from your product to make sure that that data is actually credible. Because we obviously wouldn't have wanted to go down the road of a potential product recall based upon faulty lab testing data. So that's one example of a beverage container. The other example I want to talk about would be a wearable item. So for example, something like a sports cap. And so here the potential concern could be skin contact with an item that could result in an allergic reaction. So some chemicals are contact allergens and can provoke an allergic reaction in people, which can be fairly significant. Other health concerns, for example, carcinogenicity or other effects, would not necessarily be such a substantial concern because there's actually fairly low absorption through the skin. So we'd really want to focus, I think, on potential allergy. And so how would you evaluate this risk? Well, again, you could do saline leach testing to mimic basically the effect of sweat on extracting chemicals from the product. And in fact, there are standards out there for sort of mimicking synthetic or preparing synthetic sweat that could be used to kind of mimic a long-term exposure to this material. And then once you did that testing, you would look to see if a sensitizing chemical, a contact allergen, would potentially be involved. And if so, then you would look to see what the level of exposure would be. And along those lines, you would want to consider, where the item is worn, presumably in this case on the head, under what conditions. So is it worn typically outdoors where there's a lot of sweating going on and a lot of potential leaching potential there? And is it used with something like a lotion or sunscreen, which could potentially enhance the leaching of fat-soluble chemicals? And then you would want to look at the dose of those potential chemicals in the context of the sensitizing potency of the chemicals involved. And that can be something that can be gained through toxicology studies. So again, going back to that earlier example of the different pieces of risk assessment, we would do the leach testing to look at the level of exposure and then compare that to the animal data or the toxicology data to look at the level of risk and see whether there was actually a problem. And chemicals here that would be things like isocyanates or some of the diamines that are the breakdown products. Those are well-known sensitizers and are present in things like polyurethanes. Also acrylates, which are very common in some glues, and those are potentially significant sensitizers, as well as some UV stabilizing chemicals. Another possibility you would want to probably consider is whether it's likely a child could chew on the item or potentially swallow it. Obviously not such a concern for swallowing with a baseball cap, but potentially chewing. Again, you could do saline leach testing to sort of determine how much could be extracted by the child in their mouthing activity. And again, you could compare that to some sort of toxicity benchmark, like a Prop 65 concentration, to see whether there would be any potential risk. So there are clearly ways to evaluate these types of risks for certain products like these. Now, I wanted to say something, a word of caution about the idea of hazard versus risk. These are terms that are being thrown around a lot lately, and I think it's important to really understand the distinctions between them. So hazard really represents a fixed characteristic based on something's inherent property. So for example, its inherent toxicity or its inherent flammability. Hazard does not consider the potential for exposure. It's just the properties of the material itself. Risk, on the other hand, really considers, as I mentioned before, the likelihood of something undesirable happening. So it does consider exposure, and as a result, as I sort of suggested on the prior slides, requires some assumptions, right? So how often is the product used? Under what conditions is it used? Under what conditions might someone be exposed? And as a result of those assumptions, risk is a bit more complicated to explain. Right? Hazard is sort of an inherent property, so it's not very complicated to explain whether something is toxic or flammable or what have you. But whether something has a risk requires an explanation of assumptions, and that can make things a little more complicated. And I think it's important to note that a number of newer regulations are moving towards a hazard basis. there really is a sort of an emphasis now among regulators that hazard is really the thing we want to focus on. And I think that reflects a concern that risk assessment cannot consider all possible exposure scenarios. So you may have things that you didn't consider that could be of concern, and if we just focus on the hazard, then we don't need to worry about whether we've made the appropriate assumptions. And this is really largely being driven by the GHS system. So GHS is the globally harmonized system of classification and labeling, a worldwide system of sort of labeling the hazards of your products and preparing safety data sheets. And those are really all focused on sort of hazard issues. And so, for example, here on the safety data sheet labels, I just gave I give four different warning statements that are used to, three different warning statements that are used to indicate the hazards of particular products or particular chemicals. So you might have something that says warning, suspected of causing genetic defects, or warning, suspected of causing cancer, or warning, suspected of damaging the unborn child. And I would point out that those are all warning statements that are associated with the lesser chemical hazards in these categories. So those of you who know GHS, they have category 1, category 2, sometimes category 3. These are all the lowest hazard warnings that are possible in a given category for either genetic effects or cancer or reproductive effects. So these statements, which I see as something that would be quite alarming to the public, are actually the least sort of alarming that you could possibly have. So again, there's a great potential for a lot of public alarm to be sort of created by focusing on hazard. So hazard is really becoming a focus of chemical policy. So again, there are some places where only a focus on hazard is considered. So I mentioned GHS and safety data sheets. Also, hazard is a really big focus of some of the restriction on hazardous substance lists. For example, in Korea and other countries, as well as on the corporate level, a number of companies are using hazard to identify chemicals they don't want in their products. And also a number of safer product regulations. For example, the Safer Consumer Product Regulations in California that some of you may have heard about, as well as other similar regulations that have been adopted in Washington, Maine, and Vermont. And we can expect that, I think, to continue in other states in the coming years. Now, there are cases where risk remains the focus, and I think that's important to note. So, for example, under REACH, the European REACH regulations, risk assessment is required, is used to sort of evaluate whether substances of very high concern can be used. So you get on the REACH, you get on the list because you maybe have high hazard, but in terms of whether it can actually be used, it becomes a question of risk. Also, I think most interesting, Proposition 65 in California is actually a risk-based standard. We typically think of Prop 65 as being so draconian, sort of the most extreme thing out there, but actually Prop 65, at least compliance with Prop 65, is basically risk-based. So you need to determine whether the amount of exposure would exceed a given risk level. Also, the CPSC, which I know is of interest to many of you, really does focus on risk assessment. For example, the thresholds established for chemicals like lead or phthalates are definitely risk-based. And then the FDA really looking at risk-based pesticide tolerances. So it's not that we've completely moved to hazard. Risk definitely still has a role, but we're seeing more and more focus on sort of hazard as something that's becoming of concern. And I think it's important to note that these two sort of frameworks, the hazard and the risk, may produce different results. So just three examples here. So in the case of lead, I think this is pretty clear. Lead is a well-known hazard. It's a reproductive and developmental toxin. But the risk may be negligible if the lead is contained or the exposure is limited. So, for example, if you have a lead part that's completely encapsulated, there can be no exposure, so there can be no risk, even if the lead itself presents a hazard. And one interesting example I worked on was actually lead used as a stabilizer, again, as a UV stabilizer in plastic used to make Christmas trees. Again, the exposure there is really not so significant because one is not really going to chew on a Christmas tree needle. Those are fairly sharp and unpleasant. So again, maybe some hazard there, but fairly low risk. Another interesting example is the case of polylactic acid or polylactide. So this is something that should be considered a green polymer. It's It's lactic acid. It's something that's actually produced inside the body. But because the production process involves concentrated lactic acid, and that's corrosive at high concentrations, it actually is tagged as having a high hazard, when in fact that process only involves the production process, which can be well contained and well managed and represents a low risk. So again, another case where risk and hazard really would result in different outcomes. I think a more interesting example is the case of azodicarbonamide in Subway sandwich bread. So this may be something many of you heard about. It's a very interesting case because for this particular chemical, the toxicity data indicate very minimal toxicity. This stuff is not really toxic at all. You could have grams of it and it really wouldn't cause a problem. And as a result, actually, the US FDA lists it as something that is generally recognized as safe and can be included in foods. The controversy actually arose because it's actually also used in non-food applications, for example, in yoga mats. And so in this case, it's sort of interesting, neither the hazard, that is its inherent toxicity, or the level of exposure from the Subway bread would really indicate a problem. But because it's actually used in this non-food application, you end up with this chemophobia. There's this chemical that's in a yoga mat that's also in bread. And as a result of that, Subway had to basically change their whole formulation and get rid of this chemical, even when there was no hazard or risk. So I mean, I guess my point with this example is that even a scientifically based hazard approach may not be enough to satisfy some groups who may just decide they don't like a particular chemical for basically a non-scientific reason. All right, so I wanted to move now to some chemicals and materials that the public would be concerned about, which is largely brought about by a hazard focus. So the first of these is bisphenol A. And the way I'm going to go through this is I'm going to sort of briefly summarize the state of the science, talk about some of the regulatory implications, and then talk about what might be happening down the road in the future. But so I think as many of you know, bisphenol A is a very common component of polycarbonate plastic. And so as a result, it's found in many things, sports equipment, dental fillings, lenses, CDs, DVDs, all sorts of products actually. And really the current concern with BPA started in 1997 when some researchers reported increases in the weight of reproductive organs in male offspring of mice who were fed low doses of BPA during pregnancy. And that really kind of started the whole ball rolling. And it's sort of amazing, but since 1997, there have been over 7,800 scientific publications on BPA's health effects, which is pretty tremendous. That's a pretty tremendous amount of literature that's actually been published. And what's interesting is that the gold standard studies, so those are kind of the standard, animal studies that have all the bells and whistles and all, fully developed protocols, typically conducted by both government and industry. These typically indicate minimal to no effects at low levels of exposure, levels that someone, many of us might be exposed to. So they really indicate minimal to no effects. But there are a minority of studies which report an association between low-level BPA exposure and various health effects, reproductive effects, nervous system effects, immune effects, etc. One thing that's interesting is that these effects tend to vary from study to study. So there doesn't seem to be much consistency in terms of what the various studies report. It's also important to note that diet is the primary route of exposure to BPA, largely because BPA from storage containers into food. It's also important to note, though, that BPA is quickly metabolized and doesn't accumulate in the body. So pretty much what you get in a given day, you eliminate in that day. So there's no long-term buildup, which is certainly something you would be concerned about if it occurred. And the levels of exposure, which are estimated there and shown in the table on the right-hand side, are really well below accepted daily intakes established by various regulatory agencies. So, we're looking at exposure levels that are less than a microgram per kilogram per day, whereas both the US EPA and the European Food Safety Agency use 50 micrograms per kilogram per day as the safe level of exposure. So again, even if there is potentially a hazard there, the level of risk is actually quite low. And I think what's interesting is that the National Institute of Environmental Health Sciences did an evaluation of the health risks of BPA, and they basically looked at various different types of health effects and classed them into one of 5 categories, from negligible concern, shown there on the bottom right, all the way up to serious concern, shown up in the orange there. And you can see that none of the concerns actually reached the level of concern or serious concern. At best, a few of them reached some concern, and many were either minimal concern or negligible concern. So, I think it's really interesting that this is very different from what you see in the media, where BPA is such a firestorm of controversy. Here you have the National Institute of Environmental Health Sciences saying, at most there's some concern, which I think is a much less compelling message. So what's on the horizon for BPA? So it's interesting. To resolve the concerns, the National Institute for Environmental Health Sciences initiated a $30 million study program. This was actually part of the 2009 stimulus funding. They basically developed this consortium of government labs and academic opponents of BPA, sort of trying to bring everyone together to build a consensus study design approach, have a consensus way of interpreting the data and reaching conclusions that everyone could agree with. We'll see if that's actually going to happen. But a wide array of health effects have been evaluated. The results have been published starting in about 2013, but it's unclear at this point when they're actually going to take all that information and reassess the health risks of BPA. So we're still kind of waiting on the end result of this whole process. So we'll see what happens there. But maybe more interestingly, recently, you may be aware, California put BPA on the Proposition 65 list as a reproductive toxicant. That was on May 11th of this year. And again, this was a purely hazard-based decision and was based on high-dose effects, so not the low-dose effects that people are concerned about. So basically, California has said that at high doses, well beyond what people might be exposed to in ordinary day life, it can have effects, and so therefore, under Prop 65, we're going to list it. But again, as I mentioned before, Prop 65 compliance is exposure or risk-based, and so you need to understand what the levels would be, and if you are below the levels of concern, then you don't have to list your product. And what's interesting is that the proposed safe harbor value is 290 micrograms per day. The typical intake for an adult is actually 2.4 micrograms per day, so we're more than 100 times higher than that. And the EPA EU values that I just quoted to you, the 50 micrograms per day, for a 10-kilogram infant would be about 500 micrograms per day. So we're not so far off of that with the California proposed safe harbor value. So it's not as draconian as you might expect, although it's only a proposed value, so we'll have to see where it goes. In addition, I think maybe the mere listing of BPA under Prop 65 may add pressure to be BPA-free. But important things to note there are that you can do testing, but be aware that nothing is ever going to be BPA-free. BPA is ubiquitous in the environment, so it really becomes more about the detection limit than sort of eliminating BPA completely. It's also worth noting that some of the alternatives to BPA, for example, BPS, have now been reported to be as much of a concern, as much of a hazard concern as BPA itself. So simple substitution may not be the easy route that you might think. All right, I next want to move on to phthalates, because I know these are also a class of chemicals that would be of concern. So as many people probably know, they're a class of chemicals used to lend flexibility to plastic and other materials. They're present in a huge array of materials, everything from shower curtains to transfusion materials. One thing about phthalates is that they're really not bound to the plastic base material, but they can leach out. They're sort of present there, so they are fairly migratory. And phthalates have been detected in human tissues in a number of national studies. So it is clear that humans are being exposed to phthalates. And the key concern really is their ability to possibly interfere with male reproductive development. So again, this is just sort of an example of different types of phthalates. I don't want to bore you with the chemical structures. I would just note that in the red, that's kind of the base, the red square, that's kind of the base part of the phthalate molecule. And then everything else are just things that are sort of tacked onto it. So they all are sort of very much structurally similar. So what does the science tell us? Well, so in 2001, a study indicated that one particular phthalate, DEHP, diethylhexyl phthalate, caused reductions in something called anogenital distance in male rat pups. And that basically meant that the male rats represented or showed more of a female physiology. So the bottom there, I've just kind of shown in the normal case what a normal male would look like and what a normal female would look like. So I know maybe this is not the most ideal after lunch topic, but basically you're measuring the distance between the anus and the genitals, and you can see that between males and females there is a difference. And what the study reported was that on high levels of this particular phthalate, males sort of looked more like the females. Just as an aside, there are people who actually have as part of their career sort of sexing rats by looking at this particular property. So as you go home today and someone asks what you learned, you can sort of mention that there is one interesting potential career opportunity out there. But back to the story, I think one thing that was really important here was that the doses that were used in this study were 90,000 times higher than the typical exposure levels that people would be experiencing. So it was found to be sort of academically interesting, but maybe not so much of a concern. But then in 2005, another study came out that reported that anogenital distance in baby boys was actually correlated with their mom's urinary phthalate that was measured one time during pregnancy. So this is actually shown on the graph on the right-hand side there. So the blue dots are the moms with the lowest levels of phthalates. The red squares are the moms with the highest levels of phthalates in their urine. And the anogenital distance is shown there on the y-axis. So you could see that, yes, the red squares are somewhat below the blue dots, suggesting there was a difference. But there's also a lot of sort of mix in the data. One thing that was interesting was that the phthalate that was found to be significant in the rat study wasn't found to be significant here. But because it was assumed that these moms were not people who were exceptionally exposed to phthalates, this led to a lot of concern. So you've got the headline from USC Today there, which says, common chemical may cause defects in baby boys. This led to a lot of concern. It's important to note also that this year, in 2015, two other studies were published. The Swan group replicated their study to some extent, although they found that there was only an effect with DEHP and not with the other phthalates. So that was somewhat opposite to what they saw before. And then there was a Swedish study that reported an effect for DEHP at another phthalate, diisononyl phthalate, but for no others. So the data are there, but they're a little bit muddled. So what happened regulatorily? Some of you may know this. So in 2008, Congress permanently banned 3 phthalates, including the DEHP that we've been talking about, at concentrations greater than 0.1% in children's toys and certain child care products. 3 additional phthalates were banned at the same amount on an interim basis. And these same phthalates had actually been previously banned in 2005 by the EU. Now, one interesting thing was that the CPSC action preempted state efforts, for example, those in California and Washington, to ban phthalates in children's toys and certain care products, including, I think, a broader range of products than was contemplated by the CPSC. But basically, the ban on these 6 phthalates really increased the pressure for phthalate-free products. And I put that in quotes because, again, phthalates are ubiquitous. So, again, depending on your detection limit, you may not find a product that's actually phthalate-free, even if it may be claimed to be. So what's on the horizon for phthalates? Well, I think we can expect additional limits on the phthalates and additional types of phthalates and more requirements to be phthalate-free. Again, I've just shown kind of a whack-a-mole picture there, and I think that is kind of what's going on. Certain phthalates get banned, and then industry turns to other phthalates, and then those get banned, and then they turn to others. So there does seem to be this ongoing saga. CPSC is currently considering expansion of the phthalate ban to include 4 additional phthalates in addition to the ones that are already limited. And interestingly enough, this is based on concerns about cumulative exposure to phthalates, not specific data for these chemicals. And the American Chemistry Council has really been very much opposed to this approach as far as looking at cumulative exposure. And so you can expect some battle about whether this CPSC proposal will actually go through. Maybe more interestingly, in the EU, in 2014, the EU denied a Danish proposal to ban phthalates from all products. So they wanted to ban them from all products, regardless of whether they were used for children or not. But sort of in compensation for rejecting that proposal, the EU has now proposed that those phthalates, as well as 5 others, are proposed as substances of very high concern. This was just recently proposed in June 15th. So what that means is if you want to use those substances in a product, you will have to do a risk assessment to show whether that would be appropriate and also consider potential alternatives. So again, that's a proposal that's currently under consideration. And then finally, in 2014, December, California added diisononyl phthalate to the Prop 65 list. So it now joins these other phthalates that are currently there. And again, you can expect the list of phthalates being evaluated by California to keep growing. Okay, the last material I wanted to talk about was PVC, because Dee had mentioned this is something that the members are concerned about. So with PVC, there are really 2 sets of concerns. PVC requires additives for flexibility and UV resistance, and those additives, which again are things like phthalates or metals like lead or cadmium, have their own health hazards. And so that has been a long-standing concern with PVC. Maybe more specific to the material itself, PVC is generally not recyclable, typically not recyclable because of those additives, which make the recycling process difficult, if not impossible. And PVC production is not considered environmentally benign. So PVC production requires vinyl chloride to make the polymer, and that's a carcinogenic gas as an intermediate. Again, it's contained in the production process, but it does represent a hazard. Also, vinyl chloride production itself requires chlorine, which may involve mercury emissions depending on the production process used. So there are some environmental costs with PVC production. It's also true that PVC has an extremely long environmental half-life. It's essentially indestructible and would not degrade in a landfill. So it does pose sort of a long-term concern in terms of using landfill space. And finally, the burning of PVC, either via incineration or in structural fires, can produce things like chlorine gas or PCBs or chlorinated dioxin. So again, there are some sort of end-of-life issues there as well. So, if we take a sort of broad life cycle perspective, what are the alternatives to PVC? Certainly, one can consider other plastics. You can also consider fibers, cotton, jute, hemp, things like that, metal or rubber. But then you need to consider how those materials compare to PVC overall. Do they take less energy to produce, to transport, to install? Do they and their ingredients have a lower hazard for workers, consumers, or the environment? How recyclable are they? Are they sort of in theory recyclable but not actually recyclable? Are they effective as alternatives? And maybe what's the relative cost? And again, you need to sort of find a way to compare these relative materials in terms of what their overall life cycle impact would be. So if an alternative has lower CO2 emissions during production but maybe doesn't last as long and needs to be replaced 2 or 3 times as frequently, is that really a trade-off to the positive? Perhaps not. And what you find when you look through the PVC life cycle assessments, looking at sort of the impacts of these materials, is that the metrics and scope of the analysis can be constrained and sort of manipulated in such a way that different outcomes are certainly possible. It's also true that the life cycle impacts are highly application dependent, and so for some applications, PVC alternatives do not appear to be advantageous. So for example, when we look at, for example, a leather strap for a watch versus a PVC strap, the implications of methane production during the production of leather by cows is something that really needs to be considered and adds significantly to the global warming potential of leather, which may not be so significant for PVC. So again, it's sort of how you phrase the questions that really determines whether one alternative is better than another. So what's on the horizon for PVC? I think we can expect more and more restrictions. A number of U.S. cities have adopted policies to favor the purchasing of non-PVC materials. The U.S. Green Building Council also has issued reports urging movements away from PVC. Several countries, including I think most notably Sweden, are moving towards prohibition or restriction of PVC materials. And I think multiple jurisdictions have really banned or phased out PVC manufacture or PVC packaging. And then I think maybe more significantly than these governmental efforts, a number of manufacturers, really ranging from IKEA to GM to Hewlett-Packard to Lego, are really in the process, they've announced, of phasing out PVC products. So I think this will have a major impact on the PVC market. So my last topic relates to EPA's TSCA work plan. Again, I think this kind of focuses on chemicals that are now becoming significant in the future. And so in response to criticism of TSCA, EPA's toxic chemicals regulation, EPA implemented this work plan process to help prioritize agency action. And there were basically several phases to this process. So chemicals were identified based upon their inherent hazard, the extent of their use, and their persistence, and those are known as work plan chemicals. And then all of those work plan chemicals undergo chemical assessment, which is a risk assessment, to determine whether further action would be sort of appropriate. And then finally, if the answer is yes, then EPA develops an action plan, which is a way of proposing steps to discourage the use of the chemical in certain applications. For example, by sort of regulatory limits, or maybe by developing an alternative analysis and suggesting alternative chemicals. So we have the sort of three-stage process. You identify the chemicals, you assess them, and then you develop an action plan. And I basically just wanted to mention that a limited number of chemicals already have action plans. I guess for this group, maybe most significantly would be bisphenol A and maybe the phthalates, shown 3 from the bottom there. The focus of the action plans here is both regulatory limitations. So under TSCA, EPA has for certain phthalates, for example, and BPA tried to find ways to limit the use of some of these chemicals. They've also implemented alternative assessment processes to see if there are alternatives that could be sort of suggested to industry to use on a voluntary basis. But I think we have a limited number of action plans already. Here on the next slide, I just show the number of chemicals that are undergoing chemical assessment. So again, there are 4 chemicals where the assessment has been completed and an action plan may be forthcoming. There are a number of chemicals where chemical assessment is underway and has been underway in a number of cases for a number of years. And then maybe most significantly, there are 76 chemicals where the chemical assessment hasn't even yet been initiated. So I think although this may be sort of a step forward in moving things a little faster through the TSCA process, we're still not seeing a lot of rapid movement. And if people are interested in knowing what those specific 76 work plan chemicals are, feel free to email me and I can point you to a web link that provides that information. So let me just conclude with a few points here. So again, I think my overall conclusion would be that risk assessment can be a very useful tool for avoiding or understanding product and brand liabilities, for managing recall, for communicating risk to the public. It's important to note, though, that all risk assessments are not created equal, that the level of effort really involved will depend on both the chemical as well as the product, as well as the exposure situation that would be present. And then this idea of hazard, for example, something's inherent toxicity, is really a growing focus for regulatory and product stewardship efforts. And hazard is not the same as risk, which is something I think that we really need to be careful in communicating to both management and consumers. So hazard simply reflects inherent properties. It really doesn't say anything about what the risk might be because it doesn't consider exposure. And I think that concerns about chemicals like BPA and phthalates, and also really PVC as a material, are really driven by hazard concerns and less by concerns about risk. And finally, I think we really want to investigate the current and regulatory proposed action of things like the TSCA list of chemicals before incorporating new chemicals in your process. So I think this is probably something you all do, but just I guess a friendly reminder that sort of looking at things like the TSCA list to see which chemicals might be coming down the road for further regulatory action is probably worthwhile doing before sort of putting a product into production. So with that, I will finish up again. Feel free to email me any questions, and I'd be happy to take any questions over the phone.
Great information, Tom, and takeaways. I think there are some practical ideas for approaches to chemical risk assessments that would be important from in a broader product evaluation. Certainly the regrettable substitutions issue is one that we often overlook. We did have one question. Let's see. Promotional products are ephemeral. People use them, but they tend to discard them within a year. When you do a chemical risk assessment, is the product's lifespan a consideration in the risk?
The answer is absolutely 100% yes. I think that's something that really does need to be considered. And, you know, I guess I expect CPSC or similar organizations would also have that in mind, but I think it would certainly be something to emphasize very strongly, that the product has a limited life cycle and therefore a limited potential for exposure. Now, obviously, it depends on what the health effect of concern might be. If you're thinking about something like, you know, a carcinogen, you would really want to focus on, you know, averaging that exposure over the lifetime, and therefore, if the product was only used for a short period of time, that would be something to consider. If you're talking about a more acute health effect, obviously a shorter period of use may still be significant. But yeah, clearly a very important consideration. And I guess one thing that would be also useful would be if manufacturers have information, specific information about how long their products are used, what the life cycle of the product would be. That's something that would actually be very useful in the assessment process.
So including that information in the definition of intended use, not only how you intend to use it, but the length of time that you would expect the product to be used, lifespan of the product.
Yes.
Okay. Well, we don't have any other questions right now, but I want to thank you for your time today. This was tremendous.